Hello, Chem 1A. This is Chapter 11, Lecture Video 8, and we're going to continue talking about hybridization. In the last lecture video, we talked about sp3 hybridization, and I mentioned that there are more different types of hybrid orbitals out there. The next one we're going to talk about is sp2 hybrid orbitals. This is where we mix one s orbital with two p orbitals to get three sp2 hybrid orbitals. Now, this occurs in trigonal planar structures. So, if we look at the bonding in PF3, boron actually as a central atom cannot accommodate 3 bonds unless it hybridizes. If we look at the valence electrons available in boron, there's 3 total valence electrons, but only one of them is unpaired. And because of that, technically without hybridization, boron should only actually be able to form a single bond. But because our orbitals can hybridize, what happens is the s orbital and 2 of our p orbitals mixed together to give us three equal orbitals of sp2 hybrid orbitals. And because that those 3 valence electrons then distribute 1 in each orbital, giving us 3 unpaired electrons, which allows boron to make its 3 bonds in this compound. This corresponds with a bond angle for boron of 120 degrees. That's what we see with our sp2 hybrid orbitals. They are different to each other at about 120 degrees. So just to kind of review, sp2 hybridization is when we mix one s orbital with 2 p orbitals. They combine to give us 3 total sp2 hybrid orbitals. This occurs when our electron group or electron pair geometry around the central atom is trigonal planar. That's when we're going to have sp2 hybrid orbitals. One of the important things you need to understand here is that leftover p orbitals can actually be used to make pi bonds. So an example of this could be CH2O. If we draw this guy's Lewis structure, we get carbon, two hydrogens, and a double bonded oxygen. This electron group geometry is trigonal planar. So the hybrid orbitals around carbon are sp2 hybrid orbitals. The other bond here in the double bond is actually due to side-by-side p orbital overlap, because we still have, if we're hybridizing 2 of the 3 p orbitals present, we still have 1 p orbital left that carbon can use to bond, in this case bonding with the p orbitals available in oxygen. So here's another example of that with C2H4. And you can kind of see here, these orange tube things are our sp2 hybrid orbitals. These are all the sigma bonds present. But both of these carbon centers, these are both carbons, have an extra p orbital around. And those extra p orbitals can be used to overlap side by side to give us this pi bond that is present. And we have because that we have a double bond between the 2 carbon atoms. So let's talk about sp hybridization. So sp hybridization occurs when we combine a single s orbital with a single p orbital, giving us a total of 2 sp hybrid orbitals. These hybrid orbitals occur when our electron group geometry is linear. Just like in sp2, we have remaining p orbitals. In this case, we have 2 extra remaining p orbitals that are around that can be used to form pi bonds. So like in acetylene, C2H2. In this molecule, we have a triple bond between the 2 carbons. Now this occurs due to the overlap occurring between the carbons. This is our sigma bond, and it is due to an sp orbital overlapping another sp orbital. The other sp orbital here is overlapping with the 1s in the hydrogen. Same thing over here, and that uses up the 2 sp hybrid orbitals that each carbon has in this compound. Now, after that, though, the remaining p orbitals on each carbon, each of these carbon atoms has 2 p orbitals left with which to use in a bond. Now, it does that by making 2 additional pi bonds corresponding to the other 2 bonds in the triple bond through side-by-side p orbital overlap. So each carbon overlaps one set of p orbitals, one from each side. Side by side, that makes one pi bond, and then another set of p orbitals on each carbon side by side overlaps to give us our second pi bond in the compound. Okay, so just to kind of do a quick overview of the first 3 types of hybrid orbitals. These are really cool pictures. Don't really care if you know what they look like. They're all digitally generated and very difficult to draw. So I don't really need you to be able to do anything with those. But what I do need you to know is that sp hybrid orbitals occur when our electron group geometry is linear. sp2 hybrid orbitals occur when our electron group geometry is trigonal planar. sp3 geometry occurs when our electron group geometry is tetrahedral. I also need you to know that when you have sp hybrid orbitals, there are 2 of them. And when you have sp2 hybrid orbitals, there are 3 of them. And when you have sp3 hybrid orbitals, there are 4 of them. So these are the things you should know. If you have any questions, as always, please don't hesitate to reach out either via email, office hours, or we can set up a one-on-one Zoom meeting.